Welcome back. I'm going to start this section 2, and we're going to talk a little bit more today about our maximizing fertilizer efficiency and the Alpine line of products that we have for you. So we've been talking about the K-Tech products is our Alpine K24, which is our pure form of potassium acetate, which can actually be used as blending with other products as well as being used on its own. But it's our cleanest, most pure form of potassium acetate, which we're having some really great results with, and we've talked about. So when I look forward here, we want to talk about stage foliar nutrients. You know, how are we going to look at where do we place them, or whether they go in furrow, as well as looking at other opportunities of foliar timings for streaming K-Tech products along with nitrogen. But looking at every time we go across the field, let's consider what are we using our sprayer for, the opportunity for crop protection and crop nutrition at the same time. So when we're looking at crop nutrition, we have the Alpine F18 Max, and it's a really unique blend of an 8-4-6 that carries potassium acetate. We have a full 1% of zinc and of manganese, again, which works really well with with our cereals and with our canola crops. But we also make sure we have some boron and copper, which help with plant reproduction as well as plant health. We've done a lot of work over the years with the F18 Max, and since the 2015, the trials have come up with a 72% win. We've had some really great gains in a lot of the crops that we've used them on as well, and because of the nutritional balance as well as the crop protection side of it as well. So I did some work with the F18 Max on a wheat trial we had here, and we were able to actually push a nice gain. We went from the 121 up to the 125 bushel, again with great crop health through the whole season with that. The second one is K20S. In our K20S, we now are actually adding molybdenum to this as well. I did some work last year. We had Molly in all the K20S I used, and this product is a 3% nitrogen, 20% potassium with 8% sulfur, plus it has the micronutrient package. So it really keys into looking how do we actually get into that foliar timing with fungicides and creating that plant health to make sure we're finishing. Here we actually added the K20S, and what we were looking at the control, we were actually to increase the nutrients we wanted. We actually increased the sulfur, the potassium, as well as we actually were efficient on making sure we had the boron and zinc and copper within the plants. The key part of this is because we drive that plant, and this is the trial that we had with the microbiology increase. That increased microbiology means that we are able to move nutrients through the plant. Divalent cations like magnesium, calcium are hard to move. When we can move them, that's what builds quality into our fruits. And we've seen, whether it's seeds or fruit, we've seen 14-day longer shelf life on strawberries and blueberries. Again, it's by building that cell structure. And we've done work on peas, navy beans as well. So again, keying in on the importance of molybdenum is so hugely important for the nitrogen fixation side. Boron is really key for that whole pod fill. It helps drive that GABA shunt, which makes sure we get our pollination done properly. And they just really work really nicely together as well. So here are some trials that were done in Saskatchewan, and this shows a nice increase with the K20S at 3 liters per acre. Also, the Alpine at F18 Max was at 1 liter per acre, and we got a nice gain there as well. This one was done on wheat, again, there's the K20S at 3. And again, the F18 at 1 liter. Again, we look at sometimes it's through plant health, sometimes it's because we drive more nutrients, and the foliar feeding allows that plant to extrapolate more nutrients out of the soil. This was a really nice one where we actually had the G22 at 2 liters plus the K20S at 2 liters. And I know there's a lot of work that's being done that when we put the G22 in, especially if we're in demand for phosphorus, that gives us that extra real kick in place. Another one where we actually had the F18 Max at 1 liter. And finally, we did a really neat one where we're actually blending UAN top dress, and we're adding our K-Tech products to that. Increases the efficiency of the nitrogen usability within the plant as well as uptake, and drives plant health as we go. This was an Ontario trial, which was done on corn, and we have another one that was done on soybeans. Again, we saw some really neat success stories of how we're actually allowing those plants to use the nutrition in the soil more efficiently by giving it that foliar shot, which allows for that root blast to grab more nutrients to get the plant through some of its struggling times. The next product is K19S. This is something that's a fair bit newer as far as introduction here in Canada. I was able to do a lot of work with this year, and it is a 19% potassium with a 6% sulfur, and it's designed to actually blend with UAN or 2832. This trial was done by adding 8 liters into our UAN. We always add 1 liter of boron to our nitrogen when we're mass flowing it in, because it's the neatest way to get it in, the safest way, the most efficient way to move it throughout the entire plant. On this trial, this was of course a corn silage trial, but it comes back to looking at what we're doing is we increase the yield by 5.6%. Our moisture was actually, even though we stayed green, we had more mature plants, so the moisture was down a little bit from the the control, but the crude protein and the digestible protein and the starches were all up in the plant, which means we've created that plant health. Instead of having a die and dry, we're able to finish this plant naturally, and that's key into getting all those nutrients and filling the pods and the cobs to the best of their ability. Again, we had a couple corn trials. On the one, we were 6 bushels better, and on the second one, we're actually 10 bushels better by having that potassium. And these soils are fairly fertile, but they do actually struggle with potassium because our calcium levels are so high in these soils to be able to get more potassium in the plant where it's efficient. We understand, we look at a lot of these as well, that cereals and the majority of these crops, potassium supersedes. The plant's demand for potassium is above nitrogen. And even when you're finishing canola here, you'll see the same thing. We need to have those levels of potassium. Normally, we're trying to finish everything with nitrogen alone. So even though we don't put stuff in play all the time, we can come back and look at how do we actually take advantage of foliar feed. So these numbers were done by actually the University of California, Davis. And they're looking at a pound of foliar compared to a pound of soil. This isn't replacement. This is just when we're looking at how do we actually keep these plants going. We're looking at 1 pound of phosphorus foliar fed equated to that 20 we could have put down as a sideband because of the tie-up that was in the soil. That's what was happening to make that unavailable. But we look around our potassium again, we get advantages. Whenever we put down some foliar, and partly the foliar is the part of the effect, but it's because it allows that plant to kick down, exudate, and grow a root blast that allows it to take more nutrients in. That's how we win. And magnesium is something to pay attention to. It takes 1 liter of magnesium, can do amazing. We've got some work on some hops, and they just turn dark green within a day and a half already with the magnesium on it when it's needed. So here it shows us how do we get our nutrients into play. How can Alpine help you? Well, we got the G22 as a starter. If you're on some cereals, we can look at how do we get our zinc in place. We want to make sure we keep that a 10-to-1 ratio. We're looking at our K24 if it's necessary to go in that time, or we can understand to put our potassium on at a later time, whether it's through foliar or whether we're streaming it on with a nitrogen source. Back to canola, again, we have so many opportunities. How do we actually make sure we have that sulfur in place with the boron when we're actually filling those pods to make sure that we completely fill them out and we size them up as well. Lentils, again, it comes back to, peas, it comes back to the same thing. How do we actually keep those flowers on and maybe be able to set more pods? And lentils the same, as we want to set pods and make sure we keep those pods and fill them going forward. So this is key, is our micronutrients. We want to make sure that micronutrients, we know that they don't need to go on to the great amount, but when they're needed, they're needed. And we know that we've had some results of a 10 to 15 bushel increase in corn by 1 liter of boron going on because of the deficiencies that we have. So tissue samples are really going to help us see where we're at and how we need to balance those nutrients into place. Boron is key for meristemmal growth, right? Synthesis nucleic acids. Pollination, germination, helps with rhizobium inoculation early in the season as well. It helps us fend off diseases. It builds cell structure. It's key for potassium retention within the plant as well. But we want to make sure that excessive sulfur can depress that, just because of how sulfur goes through so many changes and the activity within the soil. pH is important as well. In very high CEC soils, they have an influence to hold boron back, tie it up, not allow it to get into your system. So again, we want to look at how do we get those foliar applications in place and into the plant efficiently. This is back to the similar soil sample that we saw earlier, but when we're looking at our boron at 0.4, 0.3, 0.2, we know that boron is deficient in those plants, and it's just going to shut down, or it's going to depress a lot of things. The same as when we're looking at our copper. Let's make sure we see where our copper levels are at, and understanding that, you know, we want to make sure our sulfur to nitrogen ratios are in effect as well. And a lot of times we understand in cereals, but when we grow legumes and we're going, well, we get our own nitrogen through nodulation, you still need a sulfur to N ratio, and their nodulations aren't doing a sulfur fix, that's for sure. We did talk earlier about the laws of the minimum, and again, the laws of the maximum. Too much nitrogen causes issues, too much magnesium causes, too much boron causes issues. We saw a great yield advantage here of 0.7 with 0.75 liters of boron, but going through and thinking more is always better at 2.8, we actually slowed down the flowering. We actually knocked the yield rate out of this plant. So again, the balance is key. Zinc, again, we want to keep those ratios together. It's so important for your phosphorus uptake. You know, it's huge for enzyme functioning within the plant. Again, makes things easier. It helps the ATP become more efficient, the usage in the plant. It helps with leaf size, which is your solar panel for the plant. You know, the acetic acids, it helps from root rot issues as well in the soil. And again, we talk about, look at those ratios, 10-to-1. Make sure you have that zinc, the phos in play, because you may be actually see that all the phos you're putting on is not near as efficient as you first thought it was. Iron, we have a lot of times we have a lot of iron in the soil, but make sure that it's available to the plant. That's going to be key, because it's important for drawing sun energy towards the leaf. You know, it's important in that chlorophyll synthesis, again, working with magnesium. You know, iron is also hugely key when it comes to molybdenum functioning within the plant. You have to have those ratios, copper and iron together with those to make it happen. We also want to watch our iron to manganese ratios as well, to make sure that we're not depleting manganese by having too much iron, or vice versa. And we come back to the manganese, you know, again, we talk about that enzyme system again, that whole idea of holding things together, helping with photosynthesis, which is the creation of sugar that we need to feed the plants, and the microbials as well. You know, it's usually deficient in soils that are high in pH. We also know that the most efficient way is foliar feeding it. We get it tied up and locked up in the soil too quickly the other way. When you look at copper, you know, it's key to the elasticity within the plant, those stretching cells, the ability for things to move, and the hormones help that as well. But how do we actually create that within the plant? You know, it's a constitutive protein, and I mean, everything needs help. Again, copper and iron are key with molybdenum when we're trying to make nitrogen fixation as well. So they all have a place where they balance together. You know, copper is used as a fungicide on so many crops, and that's why, you know, we can help you if you have a little bit that's in your foliars, like the F18 Max has. Again, it helps with plant health going forward as well. Chloride is one. We don't struggle with chloride where I live, because we probably broadcast too much KCl. You know, we're up to 150 to 250 pounds, so we get our chloride. But in situations where you're not, you want to make sure that those chloride levels, you know, they stay above that 24, get into that medium range as well, so that we have that chloride for plant health as well. And most times when you add chloride to a plant, it can act as a micronutrient, it can act as a macronutrient, it will displace potassium. So you want to make sure that it's a balance, not toxic, to make sure we're getting what we want out of those plants as well. So I've done a lot of work on a lot of plants. These are eggplants, and we got the ginseng on here. I had a lot of experience, but it's really neat to understand that all plants sort of love a balance of all nutrients, not just like a kick with one. So We talked about the humic and fulvic earlier, and we talked about this molecular size. And so I thought I'd just spend a few minutes talking about the new products that we're going to be working with over the future years with ALPINE. So we know that the humic substances, they're great organic matter. It helps with the nutrient exchange and chelation. It helps within the nitrogen cycle, soil aggregation, water holding capacity. It also helps the place where microbials live as well. So when we look at humic substances, we know that we have the humans that's part of it, and that's solids, but they're non-extractable by acid or base. They're non-soluble, but they can be in products, but they're just going to stay, basically, they would be a house for a microbial. That's all. The second one is the humic acids. They're the mid-size when it comes to molecular size. They're insoluble in low pHs. They are soluble in high pHs. And again, they have a larger molecular size. They're really good to go in or with your nitrogens to help move products, to chelate products as well. The fulvic acid, which is again the smallest one, it's soluble in both low and high pHs, and it's a very small molecular size, so it can actually go in and out of the plants, similar to what the potassium acetate was, through stomata, through roots, and it's really considered one more of a foliar type of product. So when we look at how we're actually getting our humics and fulvic acids together, we want to pay attention to how they're how the manufacturing process. So that's a key question you ask, is how do they actually extract the humates? How do you actually make sure that we get the solids in, and we remove the solids and get them into a point where they stay in a solution and they're very usable within the plant and able to get through the plant more efficiently as well. So you take your high-grade leonardite, a lot of that comes out of Canada. We add our caustic soda to that. We actually do a proprietary purification system, and you end up with ALPINE Soil Max, which is our actual humic acid that we have going forward this year in a nice soft launch. We look at what are the sizes. So when you look at standard products, a lot of them have that mid-range, that 4 to 10, so that gets a little bit larger size. We actually make sure that ours stay basically below that point, that 0.1 or very much below 1. And that's all done because of the centrifugal pumps that they go through to make sure we're separating them to give the pure product that we need, that will actually work with our technology and work with our nutrients and get through our systems very efficiently without any grief. So we also look at what are fulvic acids. So fulvic acids are always part of the humic acid chain. They just need to be taken from that chain by another process. So this is something that I just grabbed from the Hefty brothers, but it just is real clear to say there's a large molecular sized humic acid, and within that is the fulvic acid. So when you look at products, you have to make sure that they are together. You don't want to have a product where they pulled the fulvic off of it already and then sell you just the humic. But when you go to the next extent, we take the fulvic acid off. So what you do is you basically take, again, your base product, you go through the process, you end up with your Soil Max, which is our actually humic product, and then you take it a step further to come with a very pure product, which is only fulvics. And fulvics are more of the oxidization side of the plant. They do work different within the plant. We also know that humic acids is shown, to help really the impact on toxicity within soil, and we know that's true, and we know that when we actually have our high selenium, that we can actually have our humics in furrow, and it protects the actually the nutrients from being tied up with it. It also keeps the plant from taking it in as well. So again, the benefits, we really like the enhancement of seed germination is key. It keeps phosphorus available longer. It's the nutrient and water uptake efficiency, places for microbials to live. It just is a nitrogen use efficiency program. It helps buffer against saline soils, and it chelates. And because the plants love and need carbon, whatever's attached to it, it does take in. But we can also be aware that, again, what happens if you have too much? Well, very high levels will inhibit germination. So you can't just say, well, let's put on 4 or 5 times because it's a great idea. There's a difference between humic and fulvic as a nutrition over an amendment where you broadcast across your soil looking at different things. You can depress root elongation, understanding that humic and fulvics are not biocontrol, right? they function differently from a different mechanism than what true fertilizers do as well. So we have to just pay attention that we look at rates, why we put them on when we do, what we're trying to work, and make sure we have synergies and not negative activities. And I do hear from time to time that people say, well, you know, if you put on some fulvic acids, you can cut all your herbicides back or change all these things. As far as I know, that as long as I'm a CCA and work in agronomy, that the rates that are put in place for a reason. And we know that our nutrients are put into place specifically to do certain things as our crop protection. So there's no recommendation of cutting rates of other things. It's a matter of how do we make things more efficient when we use them at the proper rates as well. So this just shows that as we went from basically 0 to 1 to 2 to 5 grams per hectare, that as you added the humic acid into phosphorus, they became more available and stayed more available longer. And these rates are all within a level of parameter of where they need to be, but it just shows that we could actually keep phosphorus available longer. And then when we're talking about exudates in the soil, it comes back to the same process. We increase exudates into the soil, which in turn feed more microbials, and they love it because it's a food source. Then we get to loosen other nutrients, and again, it starts that that whole inhibited chain reaction of we feed you, we get more nutrients, that gives us more strength to feed you, and it really builds on that. It's a really neat opportunity. So when we look at humic acids applied in furrow, this is a study that was done that shows that we have about an 81% win rate, that having those in furrow actually has increased the yields when you add it with your nutritional program. When we look at adding humic acids as a foliar, again, it comes back to the same process. We're seeing some really neat advantages. It's not always going to work every time. It's just no different than crop protection. We need to respray sometimes, but the overall success is still in that 75 to 80% range. And we know that from the fulvic acid side, it becomes very crucial that we get a pure product that we can get in, and the rates that we put on are fairly low. We looked at this process when we added actually the fulvic acid was in furrow here, and we got ourselves a 9 bushel gain here having that in furrow, with the starter. We actually added it to orthophosphate. And here's what happened here is we had a great increase of actually over 14 bushel. There's 15 bushel increase there as well. And we look at as a foliar, again, it becomes key to how can we move nutrition more efficiently in plants, and how do we increase those exudates by having a foliar, again, to get that root blast so we can get more nutrients out. And this was actually done in furrow with soybeans. Again, it was 3 gallons of starter of the 1034O with this in, and it just showed again the advantage of having the soil max in play. So we're looking at a 12% humic acid, a 3% fulvic acid that we'll be having in the marketplace. Our rates are going to run depending on a single or 2 or 3 rates between that 0.25 and 0.5, so it's very low use. The other one we're looking, we'll go with that 1.5 to 2 liters our humic and have that in furrow, and we can get continual applications on potatoes and other. So when you're considering different products, we want to look at the process. How is it put together? The purity, can it stay in solution? How convenient it is for me? But also we want to look at the difference between horsepower and torque. And this is actually a tractor on my farm that will pull this ripper. This car won't. And a lot of times you get products and it's like we have all this humic capacity, but what is the true torque? How is it working within the plant? So you need to ask that question of yourself as well. So that's enough about humics and fulvics. I'm excited. I've been working with them for well over 10 years, but this product is going to be a lot of fun. And this is our microbolt molybdenum and cobalt product. We call it such right now because that's what it is. It's a 40% moly and a 4% cobalt. If you add a half a liter per acre, you're getting 20 grams of molybdenum, 2 grams of cobalt. This can be split up at a 1/4 of a liter in furrow on some legumes, or we may be looking at one application of foliar. And again, we're doing some neat work as we move forward. And it becomes very important to understand, we know that moly, and you have to have that, basically that iron and copper function, but it really helps. It's an important part of why nodulation even exists. The cobalt side also is very key on not only can that the rhizobium effect be efficient, but it becomes how do we move that iron within it to make those dark red nodules, which means we're really got that energy, and it's like it's like hemoglobin almost that you can feed into your plant as well. So some of the results we had here were actually we had a 2.3 bushel gain when we were actually in some canola up in Saskatchewan. The second one was a really neat opportunity. We had G22 as a foliar. We had some boron in there as well as some K24, and we added in the MoCo as well, which gave us a really neat kick on our canola trial there. The next wheat trial was again with half a liter of the MoCo, and we ended up with a 5.6. Again, this is a lot to do with cell elongation, and again back into the energy and nutrients we feed into the plant. So basically, when you look over a 2-year period, we had a 3.2 bushel gain there, and we actually ended with another 3.7 bushel gain when it came to the canola as well. So we saw some great successes, and we're looking forward to being able to utilize this and as a soft launch this year, get some product in your hands and really see what we can do to move our crops forward. So again, our approach is very simple. Once upon a time, it was maybe a starter company. Now, what can we add to that starter? What can we put in place to make it more efficient? How can we build on our potassium side? What are the foliars that we can build on so we can actually get that root capacity built up to make sure we can keep those plants going throughout the season? So I just want to wrap up and finish up in this way. We talked a little bit about benchmarks and what we look in soil samples as well. We want to look here. We want to make sure that our magnesium to calcium ratio stays within that basically that 1.5 to 1.7 range, because that helps us with our efficiency. We get outside of that, we start to really be able to get inefficient nitrogen use. We want to make sure we look at our pHs and how do we actually correct those and keep them in line to help us with our phosphorus uptake. What's our base saturation of potassium at? How do we keep that in play? Even though we may have higher levels of ppms of potassium, how do we make sure it's available and usable within the plant? We've talked a lot about our mag and calcium ratios as well. Pay attention to our iron and our aluminum and make sure we keep those in line. Start to look at all those balances to make sure that we can be successful. So when I do a lot of my analysis, I'll actually break down what I see in a field, and we won't go through this really tightly, but if it's nice to say, here's what your soil samples are saying, here's what we need to do to balance it is an important. So when we look at things, we just pull up this benchmark and we look at where should our base saturations of potassium and magnesium and calcium be, and they vary depending on how high your CEC, whether you have clay or sand or silt. Where do our micronutrients need to fit in? What's key about our levels of hydrogen? How do we make sure we manage those as well going forward? So I get close to ending with this. It's like when you look at a crop and you say this is just done on corn, but in canola, if we have a genetic potential of a certain yield factor, and what happens is if it's 200 bushel and we actually just look at NPK alone, and if we're 98% efficient on those, we realize about 188 bushel. If we're only 98% effective on our micronutrients, then all of a sudden that is a huge amount of factors. We get those 8 different factors. It brings us down to 170 bushel. If we're only 95 precision, it's 132. And this helps us understand, why do we put a crop in that has a potential of 400 or 100 bushel canola and we pull away 35 or 40? What were those things we changed? Weather is so huge, we have a hard time, but can we actually help those plants mitigate some of the weather issues, the drought issues, by working through that? Again, availability of nutrients is key. Making sure we keep our pHs in line. How do we do that and make sure that we're not forcing the pHs in line and not paying attention to the nutrients around them as well? I like to do a lot of work with tissue samples, and these are the first tissue sample I take. These are 4 separate ones. The first one gives me a benchmark. The second one tells me what I'm using within the plant, and that is actually looks to me like a fuel gauge. So we looked across here, they see the boron was at 5.3 and 6.27 on my first test. And then we were able to increase it to 6.5 and 6.2 in those first boxes. But what's really key is we added more micronutrients in the other form, and without adding any boron, but just because of the increased exudates, The same trial, we went from a 5.33, if you look on the top line, down to an 8.10 and the 8.99. There was no boron added at that point. We just were able to extrapolate more nutrients and boron. There's manure on that farm, but we had to put the potassium acetate on and some other micronutrient packages to allow those plants to get what it needed. And the plant will exudate and it will get what it requires. Again, I like to take your whole soil samples. I like to break them down, mark them red and green, where we're high, where we're low, and then make and work through those and say, so how are we going to adjust all these? Put a story around it so it makes sense for yourself. And at the end of the day, then you can come back and say, here's what I need to do to balance my soils. So the team we have in the West is incredible. I mean, in Eastern Canada too, I don't want to take anything away from any side, but the amount of different kits that have been added to make sure we can apply our nutrients more efficiently are huge. And here's a case where we actually use a fluorescent bulb when we're putting on fulvic acids or humic acid, so you can actually still see things reacting in there. But the equipment that's been put together to allow us to use our nutrients and grow your crops more efficiently are second to none. And I know there's a lot of competitors that actually, they will take the advantage. They will order a kit, have our guys put it on, use a little bit of product and switch to another company. It's pretty interesting how that happens. But at the end of the day, we're going to stay very precise and very committed to making sure we give you the equipment that you need and provide the products that actually work well within your system. So take advantage and visit Carlisle's for your G22, your micronutrient packages, your foliar needs, and potassium acetate. And as Francis Childs always says, in order to achieve yield levels that we've never reached before, we'll need to do something different that we've never done before. So thank you for your time, and I appreciate that we've had the opportunity to present to you. Have yourself a great day and enjoy the 2021 season.